All right, guys, we're going to go ahead and get started. So it is day 2 in geometry. And yesterday we practiced measuring in inches with a ruler. And then we started talking about postulates. First of all, I want to remind us what a postulate is because we're going to hear that word a lot in geometry. So I'm going to pull up the notes we took yesterday. Remember, a postulate is just a fancy word for a rule that we are going to hear a lot in geometry that we just accept is true. We're not going to have to prove the rule. It's a rule that some mathematician centuries ago proved was true, and we don't have to do that work over again. So we first started talking about the segment addition postulate, where if you have a point in between 2 points, then from point A to B, if you add that from point B to C, you're going to get the full length of point A to point C. So we did quite a few examples with that, and we started working on this worksheet, and that's what I had you guys work on during the Do Now. So let's take a look at this together. And I believe we did number 1 together yesterday. But we'll go through it again real quickly. For number 1, how would I set up my equation? Anybody know how I would set this up?
It'd be 2x plus 20
Perfect.
plus 7 equals x plus 40.
Perfect. 2x plus 20 is the first half of the line. 7 is the next part of the line. So we're adding those 2 bits together to get the overall total length of x plus 20. So we have our equation all set up. What is the first thing we need to do once we have everything set, added together, equal to each other?
Get rid of the side.
Get rid of the x's, cancel things out.
Combine
Like terms. That's what I'm thinking of. Combine like terms. Can anybody remind me, what does like terms even mean? They have the same variables. Absolutely. So in here, we're not looking at exponents, thankfully. We're just worried about numbers and variables. I have x's here, and then I have numbers without x. So I have a 2x on this side of the equal sign, and then I also have an x. How could I combine those? Yeah, let's subtract x from both sides. That way we don't have to have a negative x. Save us a little work later down the road. So those will cancel. 2x minus x will leave us with just x. We'll bring everything down. Plus 20 equals 20. What would I do next?
You forgot 7.
Oh, wow. Thanks. I make mistakes, guys. Call me out. Okay, so plus 7. I would have got that wrong. Okay, so I have x plus 20 plus 7 equals 20. Did I combine all my like terms? No, what else should I combine? The 20 and the 7. I remember doing this yesterday now. Okay, so 20 plus 7 gives me what? 27. So I'm going to bring that down. X plus 27 equals 20. What would my last step be? Good. We're going to subtract 27 from both sides, and we'll get x equals negative 7. That was number 1, and we did go over that one yesterday, but that's just a refresher. So let's go ahead and look at number 2 now. Number 2, who can tell me how to set this equation up?
2x plus 20 plus 8 equals 20 plus x.
Perfect. 2x plus 20 plus 8, that's the other part, equals the big length of 20 plus x. Oopsie. So, just like we said in number 1, we want to combine like terms first. So, what like terms do I have to combine? Yep, I've got 20 and 8. And what would that turn into? 28. Okay. Then what could I do? I'll bring everything down.
Let's subtract the x.
Yes, let's subtract that x from both sides. So we can get rid of it there. 2x minus x. That leaves us with x by itself. Bring down the plus 28 equals 20. And what is my last step? Minus 28 from both sides. Good. And that's going to give us an answer of x equals negative 8. Good. Good, good, good. Okay.
I did the opposite of that.
Did you get the same answer? So do you mean like you set your equation up different sides of the equal sign?
I put the x down on under 2x,
Uh-huh.
and then I put the x down, and then I did the adding the 20.
Oh, so you combined your x's first and then you did your 20 plus 8?
Yeah.
Gotcha. You can absolutely do that in either order. It'll work the same way every single time. So good thing to point out. I bet you're not the only one that did it that way. Okay. Let's look at number 3. How would I set this problem up?
3 plus x
Say 3 plus x
plus x plus 6
okay,
plus 7.
plus x plus 6
No.
equals 7. Okay, so this one's a little bit different because now we don't have x's on both sides of the equal sign. We just had a regular number without a variable as our total length. And I think this one may have thrown a few of you off at first, since the first two were a little different. So how are we going to combine like terms when the terms are on the same side of the equal sign? Yes, we're just going to add these together. X plus x gives me 2x.
And then 3 plus 6.
Yes, you can actually do it all in one step if you want as well. So you're not making a million lines of work.
2x
I
plus
see
9
that.
equals
Yeah, good. So we combined our x and x to get 2x. We're going to also combine the 3 and 6 to get 9. And I'll bring down my equals 7.
When you take that 2
Uh-huh. Now what do I do?
subtract 9
Yes.
from both sides.
Both sides, good. Those will cancel. Then what?
2x equals negative 2.
2x equals negative 2.
Gonna divide by negative.
So it's negative 1.
Yeah, 2.
Negative 2 divided by 2.
Yeah, 2.
Okay. I'm hearing a couple of different things. Whose work looks a little different than this right now?
Divide by 2.
Just divide by 2 and we'll get negative 1 on both sides? Okay. So divide by 2 right here. Those cancel. Negative 2 divided by 2. Not 1/3.
Negative 1.
Negative 1.
Yeah.
Negative 1. Now, let me take a look. Nope, that's right. For some reason, I was thinking it would be positive 1. I think I may have told somebody incorrectly earlier. That was you. My bad. The answer is negative 1, not positive. I'm sorry.
You're good.
I remembered seeing a 1 on the answer key, and I forgot there was a negative. Ah, sorry if I told you that was right.
Yeah, right.
It's negative 1. Okay, any questions on this problem, considering I confused half of you?
I didn't get that the first.
Did you get it the second time?
The second time, yeah, but the first time. no.
What'd you do the first time?
Complicated.
Do you think maybe you subtracted the x's
I
and they
put 3
canceled?
plus x plus 6 equals 7.
Okay.
6 was x down.
Okay.
And I guess I didn't add 2 on it.
Oh, so we put x and x together just to get like x.
Yeah.
instead of 2x.
And then I did divided, I put 3x.
Oh, I see. So you actually did 3x. So like you combined the 3 and the x to make, okay, that makes sense. That's so easy to accidentally do, especially whenever we have like super tiny typing. I'm not a huge fan of pre-made, well, not pre-made, but these worksheets that I'm used with this program to make because of the text being so small. It's easy to kind of mix up the symbols, and I'm not sure how to make it bigger yet, but if I figure that out, you will see worksheets with larger print. So hopefully I can make a few with bigger numbers because I have a hard time seeing it myself. So appreciate you sharing. Okay, any questions on number 3 or are we ready for 4? All right, let's do 4. How do I set this one up?
6 plus 2x.
Yes, 6 plus 2x minus 6 equals what?
X plus 6.
Yes. Did the 6 plus 2x minus 6 equals x plus 6. So, how do I start?
Get rid of the x.
How? What am I going to do? Subtract the x. Good. Subtract x from both sides. And then those cancel. And then
minus 6
okay, so I have an x here.
minus 6 equals 6.
What am I missing?
6 plus.
There's a 6 there still.
Oh.
That's okay. 6 plus x minus 6 equals 6. Wow, it's a lot of 6s. Okay, yes.
On the left side of the equals, the positive and minus 6.
Yes. Out of 6 minus 6, combine these, they equal 0. 6 minus 6 is 0. So really, these cancel out on the same side. So we can just mark them off. There would be no reason to write 0 plus x. The 0 is not necessary. So I just have x equals 6. That's our answer, isn't it? Yes, just double check the answer key. That's correct.
That's tricky.
That is tricky. When they cancel on the same side of the equal sign, it feels like you did something wrong. But you didn't. Numbers can work that way. It's uncomfortable, but it's correct. Do we have any questions about this one? This one was a little weird. Did anybody get a different answer and maybe want to share a mistake they made? I think sometimes mistakes help.
We got the right answer, but we just did the work a little bit different.
How do you do your work?
So we've got this 6 plus 2x minus 6 equals x plus 6.
Perfect.
We subtracted the x, left us with 6 plus x minus 6 equals 6.
Mm-hmm.
We subtracted, no, we added 6.
Oh, okay. I'm going to write how you did it because I bet other people did it this way. So ignore this. I'm going to get to this step. 6 plus x minus 6 equals 6. Did you add 6 to both sides?
Yeah.
Okay, so we add 6 to both sides.
Which left us with 6 plus x equals 12.
Yes. And then,
We subtracted 6.
yeah.
Yeah. 6.
Yes, so you would get x equals 6. Different word, same answer. That's the cool thing about when you start getting into this higher level math is there is infinite ways to solve the problem to get the same answer. So just keep in mind that your work might look a little bit different than mine, and that doesn't mean it's wrong. As long as you're getting the same answer and what you're doing makes sense, that's okay. That is so okay. And I love it when you guys share different methods. Because I'm sure somebody else did it the same way and is thinking, what did I do wrong? Nothing. You did it right. It's just a different way to do it. Any other ways or questions, comments on number 4? Okay. We ready for 5? Okay. Number 5. How should I set this one up?
X plus 1 plus 7 equals 2x plus 5.
Plus 1 plus 7 equals 2x plus 5. What should I do first?
X plus 1 plus 7 equals 8.
Okay, so the 1 plus 7 gives us 8
And then it equals to 2x plus 5.
equals 2x plus 5. What am I missing over here? The x. It's still x plus 8 equals 2x plus 5. Then what should I do?
Yes.
Subtract x. Okay, let's do that. Okay, my x's cancel. Then what?
8 equals
Yes.
X plus 5.
Good. 8 equals x plus 5.
Track 5 from both sides.
Yes. Subtract 5 from both sides. Those 5s will cancel and we'll get x equals what?
3.
3. Perfect.
That too, I did do it.
You got the same
But a
answer
different
though?
way.
Did you do your x's first and then your numbers? Yep, yep. A lot of people, I would say, especially if you started all the way back from pre-algebra with me, I usually teach to do the x's first just to help you stay organized. So if that is a habit of yours, that may be my fault. And that is also totally fine. You can do it either way. Sometimes doing x first, though, is just a good habit so that you make sure you're getting dotting all your I's and crossing your T's, whatever. Okay. Questions on 5. Okay, let's do one more together, number 6. And then I'm going to open the floor to any on the backside that maybe any of you might have struggled with or not. Maybe we feel good about it. We'll see. Let's look at number 6 then. How do I set this one up?
x minus 1 plus x plus 3.
Good. X minus 1 plus x plus 3 equals 10. Hey, what should I combine? My x's. I have an x plus x. What happens when I combine them? 2x. Process off. Can I combine anything else at this step? Yes, I've got -1 plus 3. What is that?
2.
Plus 2 equals 10. Bring that down. Perfect, perfect. Okay, what should I do next? Subtract 2 from both sides.
2x equals 8.
Yes, 2x equals 8.
Divided by 2.
Divide by 2. And we'll get x equals 4. Awesome. How'd you guys do on the first page? Do okay? Okay, did anybody get all of them right? Yeah, good job, guys. I love that. Okay, so on the back side, I am going to write the answers to all of them. And if you got an answer that's different from what I tell you, raise your hand and let me know and we'll talk about it. Okay, can I move this or does anyone still need to see this before I flip it over? Okay. Okay, here, I'll wait. Oh, good, I'm kind of putting my hands all over the page. Alright. Flipping to the back side. Stop me if you want to go over it. I'm gonna just kind of rapid fire write out the answers. And if you haven't finished one of the problems and I give you the answer, feel free to write the answer down. So if you wanted to practice later, you have it so you can check to see if you get it right. Number 7, we got x equals 5. Number 8, x equals -2. Number 9, x equals -8. Number 10 equals +8. Okay, put a star by that. Once I give the rest of the answers, we'll go over it. Okay, number 11, x equals -8.
That one already helped.
Yeah, same.
Okay, perfect. Let's start by it. We'll go over those two for sure, 10 and 11. Actually, I'll go ahead and circle those. I know we want to look at 10. I know we want to look at 11. Number 12, we get x equals 0.
Oh, that's right.
Yeah. Okay, number 13, x equals 1. And number 14, x equals 7. And that's all the answers. So as of now, we want to look at 10 and 11. Are there any other numbers that you would like to go over before we move on? 14? Okay. 10, 11, 14. Any other?
7.
Number 7? Okay, I will circle that one too. 7, 10, 11, 14. Everybody good with that? 7 is a little different. Okay. So now that we're getting into the requested problems, I'm going to request in return that as we go through these together, we're going to do them really slowly and not try to like speed through it, just so that we can make sure that everybody's got it, everybody feels good before we go to the next thing. Does anybody still need to see these answers, or can we begin working through the requested problems? Everybody good on these? Okay, I'm gonna move this to the side. And I'm gonna work these out in my notebook. So I have a little more space and I'm gonna do it a little more slowly. So I'm gonna go ahead and title this as a page of notes. You don't have to do it this way. I'm just gonna do that so if I need this paper later, I don't lose it. So geometry. So we are going to start with number 7. So for number 7, we have a line that is Q, R, S. And from Q to R, we have 2x minus 3. From R to S, we have 2x minus 7. And from Q to S, the whole length, we have 10. So, let's see. So, whenever we're setting up a problem, the way that we've been doing it with all the past ones is we are starting by adding together the two smaller sections. QR is part of the whole. RS is a small section of the whole as well. And the whole from Q to S is 10. So we need to add the blue and the pink to get the purple. A little art class for you. So we're going to start with 2x minus 3. That's our first part. We're going to add that to 2x minus 7. So plus 2x minus 7. And what will that be equal to? 10. Good. When we add the two smaller bits, we get the large length of 10. So just to write out some little steps here to the side, the first thing we always want to do once we set the equation up is we want to combine any like terms. So let's start by just highlighting or circling or making some indication of what terms are like. I'll start from the beginning with 2x. Do I have any like terms that I can combine with 2x?
2x.
There's another 2x. So I've got 2x and 2x. Those will go together. And that'll give me 4x. Perfect. Now I'm going to go to the next term. And when I say term, do you guys know what I mean by that? Okay, so I'm just want to make sure we understand. A term is basically another word for a number. It just doesn't say specifically if there's a variable on it or not. So a term could be 3, a term could be 2x, a term could be 12x to the 10th power. It is any one item that belongs together and is not separated. So 2x and 2x are both terms.
So wouldn't it be 4x subtracted from?
Well, let's see. Let's look at our -3. Do I have any terms that can I combine with -3?
-7.
Yes.
-7. So we need to add -3 plus -7 next, or we could think of it as -3 minus 7. -10. Oh, I hear that. Okay, and then we'll just bring down the rest, equals 10. Okay. You guys see where we got that? Okay, so now our equation looks a little bit less scary. Once we've combined our like terms, which we're done, there's nothing really left to combine. Now we just solve the equation. And I just abbreviated that because the equation was not going to fit. So what should I do here? Good. Add 10 to both sides. I didn't see your hand, Erica. Did you have a question or were you going to help
Just
solve
gonna
it?
answer.
Gotcha. You want to tell me what to do next?
What I did is I flipped the equation around, so it's 10 plus 10 divided by 4.
Ah. So Erica does, she solves her equations in a really cool way. Instead of lining it up like I teach it, I'll show you next what you do. So we added 10 to both sides. Now we have 4x equals 20. I'm going to explain your method after this. And then you said you divided by 4, right? Okay, so we'll divide by 4. 20 divided by 4 gives us 5. X equals 5. So if your brain works in a similar way, and if this doesn't make sense to you, you are welcome to block it out. If it does, excellent. Erica, since I've had you all the way back in Algebra 1, I love this because it's a very creative way to do it. You like to flip the equation and kind of just do it backwards. So you're starting with what's after the equal sign, the 10, and then you see, okay, I'm going to do the reverse, plus 10, and then I'm going to do the reverse of times 4. I'm going to divide it by 4, and you're going to do it kind of in order. I know that's 20, then divided by 4, and that gives you 5. You do get the same answer that way. It works just as well. I think that's really neat. If you're used to the traditional way of stacking it up and down, just keep doing it that way, but this is a great way to do it too. Okay, questions on number 7. Okay, so that was 7. Let's look at 10 next. So for number 10, I'll just kind of redraw that picture again. We have from E to D to C, x minus 3 is ED, 2x minus 13 is DC, and from E all the way to C, the whole length, 8. Okay. So I'm going to do that highlighting thing again. Here's part of our whole. From D to C is the other part. And what is the whole?
X minus 3.
X, yep, go ahead.
Plus 2x minus 13. Equally.
Perfect. When you put these two together, that creates the whole, and it'll be equal to 8, the whole length. So let's write that equation out just like you said. We have x minus 3 plus 2x minus 13, and that's all equal to 8. Okay, so what's the first step now that I have my equation set up? Combine like terms. What can I combine with x? 2x. Okay, and what will that give me? 3x.
Victoria.
Okay, so you see where you messed up.
Minus
Gotcha. Okay.
so 3x minus 3
Huh? Minus 3 minus 13.
equals 8.
So let's see. Now I have. Sorry. That's okay. Minus 3. And I went ahead and underlined the minus 13. Do we agree those are also like terms?
Yes.
Yes. And what will that give me? I heard Shana. Minus 16. Good. Now I have 3x minus 16 equals 8. Sometimes it helps to cross things off as you go, just so you know you're not using them anymore. I have definitely accidentally brought something down that I already used and forgot about it. So do what you need to do to get it organized. So now we have 3x minus 16 equals 8. What should I do at this step? Add 16 to both sides. Perfect.
16's cancel, so then it's 3x equals 24.
Yes, 16's cancel. We break down our 3x equals 8 plus 16 is 24.
That's where I kept getting stuck. I kept getting the answer 24. I didn't combine my
Oh,
2x and my x.
I gotcha. I think sometimes it's so easy to accidentally like subtract these. Because we're so used to combining like terms on opposite sides of the equal sign where we have to use those opposites. It's a good thing to remember. If it's on the same side of the equal sign, we're just adding them. But good thing to point out. And then what do we do?
Divide by 3.
Divide by 3. Good. X equals, what was it? 8. Perfect. X equals 8. If you didn't get this one, do we see what we did? Any other questions on number 10? I don't want to move on yet. If anybody is still copying this down, does anybody need another minute to write? Let's look at number 11 now. Number 11. We've got one segment with I, J, K. And from I to J, it's just 5. J to K, it's 2x plus 17. And the total length of the whole segment is x plus 14. Okay, so here's where sometimes the colors can come in handy. We're still adding the two small parts, the blue and the pink, to equal up to the whole, which is the purple. So how would we set this equation up?
5 plus 2x plus 17.
Yes, 5 plus 2x plus 17
Equals x plus 14.
yes, equals x plus 14. Now, why is this one different from the last one we just did?
Because the bottom line is an equation. Or
Yeah.
it has a variable.
Yes, there's a variable in our whole length and the bottom length here. In the last one, we just had a number. So when we combined our like terms, the x's were on the same side of the equal sign. So we have to do something different here to combine our x's since they're not on the same side of the equal sign anymore. So maybe let's just stay consistent with messing with the x's first. I've got 2x on this side. Do I have x's anywhere else? Erica?
Cross out the X on the right side and
Uh-huh.
then cross out the 2 on the left side.
Yes, basically what you're doing. So we could cross that out, cross that out. Whenever we subtract x, both sides, it cancels that and it gets rid of the 2 basically. 'Cause we're going to end up with x by itself. Okay, so let's see. You guys see what just happened there? I did minus x on both sides, and then I'll just bring everything down. Now I have 5 plus x plus 17 equals 14. Do I have any more like terms? Yeah, the 5 and the 17.
22.
22. Cross those off. And what do I bring down?
X plus 22.
Good. So I really have x plus 22, or you could do 22 plus x. Both are just fine. X plus 22 equals 14. You can also do 22 plus x. I'm going to say that again. I saw some confused faces. Yes. Go ahead, Shayna.
Subtract 22 from both sides.
Subtract 22 from both sides.
X equals -8.
X equals -8. Perfect. Perfect, perfect. Questions about number 11. It's starting to make more sense the more we do. Starting to get it? Okay, you ready for the last one, number 14? Okay, let's look at 14. So 14, last one we'll do now. I have 8 from 8. From I to j, 2x minus 6. And my total length from h to j, x plus 9. Okay, so I'll do the colors again. My whole is x plus 9. And then I've got my 2 parts, 2x minus 6 and 8. How would I set this equation up?
Plus 2x minus 6 equals x plus 9.
Perfect. 8 plus 2x minus 6 equals the total of x plus 9. So there is our equation. What should I do next?
Subtract x from both sides.
Yes, let's subtract x from both sides. Those cancel.
Which will be 8 plus x minus 6.
Good. Now I have 8 plus x minus 6
Equal 9.
equals 9.
Then I subtract 8 from both sides.
Okay, subtract 8 from both sides.
Yeah.
Okay, that would absolutely work. Okay, so the 8's cancel. I'll bring down,
X take away 6 equals 1
yep, and then what?
plus 6 on both.
Plus 6 on both sides. And we should get x equals 7. There are about a million other different ways to do this. My first instinct was to do 8 minus 6 first and get x plus 2. But this way worked too. There are lots of different ways you can do this and get the same answers. This is a correct way to do it. Okay. Any questions about 14? Any questions about any of this?
We go with 9.
Number 9? Yes. Look at number 9. Can I move this? Does anybody still need it? Okay. Number 9. Oh, number 9, I have x plus 9. And I have 14 plus x. E, U, V. So, how do I set this equation up?
Plus 9.
Hmm?
14 plus x equals 7.
Perfect. X plus 9 first, plus 14 plus x equals my whole of 7. What should I do now?
Combine like term,
Combine like terms, yes. What do we want to combine first?
X and X.
X and X. Let's
Which
do
would
that.
be 2X.
Yes, that's going to give us 2x.
And then 9 plus 14,
Yes,
which is gonna give us 23
yes. So we have 2x plus 23
equals 7.
equals 7.
Then you subtract 23 from both of you.
Yes, now we'll subtract 23 from both sides.
And you have the 2X equal -16
Negative 16.
and divide 2 on both sides.
I by 2 on both sides. And we get x equals
-8.
-8. Perfect. You see what you did?
Yeah, I'm supposed to divide.
Gotcha. Yes,
Is there any way we can do number 12?
number 12. Yep, we can do 12. Yeah, 12 is the one that was 0.
Yeah.
So let's look at that. Okay.
Don't you?
So 12, I have part of my line here. I've got 7, and then x plus 1, and my whole. Sorry, I'm getting a little sloppy. I need to slow down. 2x plus 8. How do I set this equation up first?
7
Huh?
plus X plus 1.
Perfect. 7 plus x plus 1
2X plus 8
equals 2x plus 8. The two parts add together to equal the whole, same as always. Okay, what could I do from here? Yes, Erica?
So +1 equals 8.
Yes, 7 and 1 give us 8. So I'll write down x plus 8.
Cancel out that first x and the second x into just x.
Perfect.
2x.
Okay, so basically we're subtracting x from both sides. Cancel that and give us 8 equals x plus 8.
8 plus what equals 8? 0.
Aha! Yes, this one you can even just use some reasoning to solve, because what number can I add to 8 to keep it 8? 0. If I add 8 plus any number that's not 0, it's not going to equal 8. X has to be 0. We can double check that though by using our normal process. Subtract 8 from both sides. Those would cancel. We bring down our x equals 8 minus 8 is 0. X equals 0. Okay. Do we have questions on 12? Do we see what happened on that one? Okay, how do we feel? Feel okay? Okay. So here is what I'm thinking. Let's take a little break. It is 10:11. I I'm gonna say let's take like 15 here. So come back around, what would that be? 10:25, 6? Okay. I'm gonna say we're gonna try to start back up no later than 10:26. Okay, so I'm gonna pause this. You guys, bathroom, drink, whatever you need. You can stay in here if you want. We will move on to our next topic when we return.
Are we trying to this?
Oh, yes, please. I'm sorry, guys. Thank you for reminding me. These papers, the Solving for X segment addition postulate, please write your name on them. Turn them in. Please turn them in. This is how we're making up for not having as many days. I'm going to be taking grades on our classwork a little bit more this term. And I will write that up on the board so we don't forget. And okay, so we are back from our break, and we're going to start a little page of notes to continue from yesterday, and we're actually going to move on to something totally different now. So I'm just going to title my page to start. A2 notes. And today is Wednesday. On 8, page 1. We are going to start by just talking about a couple of vocabulary words and just define some of the things that we're going to be talking about. So, first, we've been talking about line segments. But we also want to talk about lines and all the other features and things that we're going to see in geometry. So you may want your ruler for this so that we can draw some straight lines. I'm going to have a few pictures up here that we'll draw and label just so that we know what we're referring to whenever the next few things come about. So the first thing I'm going to have us write is the word line. Line. A line, something that looks like this. It goes straight across in two directions, and we put arrows on the end of each side, each angle, I don't even know what I would call that, on each end of the line. And that shows that our line extends in both directions forever, infinite. It never ends. A line has no end points. Now, what we've been working with today and a little bit yesterday is called a line segment. Okay, and that is very similar to a line, but it does have endpoints. A line segment is just a piece of a line, part of a line. Now, before I write the word, I'm going to draw the picture. It's only a 3-letter word, so you don't need to leave too much space. Or if anybody knows what this is called. We have one end point, and then one end
Array.
goes forever. Array! Yes! Array. Array has one end point, and the other end extends forever and ever and ever. And that is just spelled R-A-Y, array. I like to think of this as like a ray of sun, because the sun has one center point, and then its rays shine on forever and ever and ever in every direction. But there is one end point, there's a center point there. So we have a line, we have a line segment, we have a ray. Now we're going to start thinking in more than just one dimension. We're going to talk about angles. An angle has one point, and it's made up of two rays that share a point. So it doesn't matter exactly how you draw it. I'm going to move down like 4 spaces just to give myself some room. And I'm going to start with a ray. From the beginning point right here of this ray, I am going to put my ruler right over that dot, and I'm going to draw another ray coming off of that same point. This is an angle. You see angles everywhere. At the edge of every table, the sides of the table meet at an angle. Every wall meets at a corner that creates a certain angle. There's angles in everything that you'll do or see. Now, angles, rather than measuring in length like we do with line segments, we measured line segments in inches and we used a ruler. Angles get measured in a different way. Does anybody know what units we use to measure an angle? Degrees, yes. So here's what we're measuring with an angle. I'm actually going to use a different color here. And I'm going to draw this little arc. And I'm going to write inside my angle that we measure in degrees. D-E-G-R-E-E-S. We measure in degrees. Now, I'm actually going to pause this for a moment while I grab something. So we are going to be using a math tool today. Each of you will get to use one. I have a whole bunch. This is called a protractor. Yes, this is a protractor. This is an angle measuring tool. Each of these little measurements tells us a certain amount of degrees. So, for example, if I wanted to measure this angle, here's a quick tutorial, and then we'll go in more depth here in a minute. I would take my protractor, and I would find this dot, this hole in it. That's where I'm going to line up with this point. And then I'm going to make sure that my angle, this bottom ray, goes through the line right here. And that it also goes through the line right here. When it's lined up properly, now I'm going to look at, let's see, here we go. What direction is my angle opening? We're starting here at the bottom. So
39.
Yes, it's going to be about 39 degrees. Now, how do you know that it's 39 degrees and not 150 or 141 degrees?
Your bottom line starts at 0.
Yes. So if you'll notice on your compass, there are two sets of numbers. There is from 0 to 10, 20, 30, 40, 50, all the way up to 170 on the inside. But there's also numbers on the outside that start from 0 here and go up to 170. Technically, it goes up to 180. They just don't have that written on here. We are always going to start from wherever the bottom line, the bottom ray, is touching and say, do the inside numbers go up from 0 to 10 to 20 to 30, or do the outside numbers go from 0 to 10 to 20 to 30? In this case, it's the inside numbers. So I would just follow until I see the end of the other ray, and you can see that it hits almost at 40, right about 39 if we had to estimate more exactly. So this is great and all, but it's going to make a lot more sense if you guys have this in your hands. So I am, again, going to pause the recording, and I'm going to pass out some protractors, and you all are going to use one today. So, pause. All right, so everybody should have a protractor. And I just gave you a worksheet like this as well. So let's look at this first one where it says use a protractor and a ruler. So you need both to draw each angle. So you have been given for each angle measure a ray. There's a point. Now they didn't draw the other arrow, which there should be an arrow there, but you know, it's okay whether it has it or not. You want to take your protractor and make sure it's facing the correct way. Make sure you're not reading your numbers backwards. The top should say 90, not 09. It should say 90. And this little tiny dot is going to be our end point where we want to put the hole in the bottom of the protractor. And we want to line it up right there. Yes.
Just started drawing with my own stuff.
You're
I made my own center drawing.
And that works too. Absolutely. So make sure that from the point, your line or your ray goes through this little line outside of the hole and that it is lined up here with the line right there. See that? There's really three important pieces that need to be lined up. This line, and the hole in the middle. Okay. Now, you might be able to tell these protractors are not completely accurate. You'll notice that this is not perfectly straight. If it was perfectly straight, it would be closer like to that maybe. But we're going to work with what we have. So, you know, it's okay. We're not construction workers. We're not building blueprints. So it's all right.
It was really fun to get one of these to be a nice metric grid.
I bet. That would be really cool.
That was not answer.
Oh, really? Not this kind. Maybe a good one would be fun to do it with. Okay, so here's what we're going to do. We are going to start looking at either the numbers on the inside or the numbers on the outside. Since we want to start from the right side of the protractor and the angle will open up this way, are we looking at the inside numbers or the outside? The inside numbers. Why are we going to use the inside numbers? Well, because, yeah, this is where the end of that ray is touching. It's pointing towards these inner numbers. But also, as the angle opens up, we can see that the small angle should be, that's about 10 degrees. That's not 170 degrees. Then we get 20, then we get 30, then we get 40, 50, all the way up. We want to draw 175 degrees. So I'm going to look on the inside numbers until I find 170. And then I'm going to go trace that up to here. It lines up with the 10. And I'm going to go 5 more. 1, 2, 3, 4, 5. And I'm going to put a little mark here at the 175. Then we can remove the protractor. And this is where we have a ruler. Now where I put that mark, my ruler goes. And I want to line my ruler up to touch this point and the marking that I just created. This is a very big angle. We want to connect those. And I'm going to put an arrow at the end. This is a very big angle. Now, once you've drawn your other ray and they're connected here, to label it, we like to draw that arc inside the angle. And we're going to write the measure right above the arc, 175 degrees. And you've drawn a 175-degree angle. This is a very big angle. Probably not the best one to start with, but that's what we did. Okay, let's look at the second one. Now we're going to draw a 90-degree angle. So I'm going to line my protractor up again. Make sure everything is touching correctly. And again, am I looking at the numbers on the inside or the outside? Inside, because we're starting from the right, opening upwards. So we're going to go up to 90. Make a mark there. You could mark it outside, but we'd be running into the angle above. I'm going to mark it right here on the inside at 90. Take away my protractor. And I'm going to connect this point to the marking we made. Does anybody know what's special about a 90-degree angle? It's a right angle, okay? A right angle is a specific type of angle. We're going to talk about angle types here in a minute. We'll put it in our notes. But a right angle is the only kind of angle that we actually don't draw an arc inside of. We draw a box inside of it. Does anybody know why we draw this little square in the 90-degree angle? Why, Erica?
Because the right angle, 89 degree.
Yes. Yes, it's to show that this is an exactly 90-degree angle. It's not 89, it's not 91. The other reason we draw a square inside is because if you have a square shape like this is a square, all of the angles inside of a square are 90 degrees every time. So a 90-degree angle, we indicate that by drawing a little square inside of it. So this one, you actually don't have to write the 90 because the square tells us it's 90. You can if you want to, just for good measure, but the square is good enough. Okay, and then I'm going to show you one more, and then I want you to try a few by yourselves. So we're going to look at number 3, that's 20 degrees. I'm going to line up my protractor with the circle, the hole right there. It's going to bug me that these aren't accurate. "20 degrees. I'll be right here. So I'm going to trace, since I can't really mark under the 20 very well, I guess I kind of could, but it's really tight. I can trace that 20 or follow it out to the edge right here at 160. But this is a 20-degree angle. I'll pull my protractor away, take my ruler, and I'll connect the point to the marking we made. Once you've drawn that, same thing, we want to finish by putting an arc inside and writing the measure of the angle, 20 degrees. Okay, so there are a few examples. There's numbers 1, 2, and 3. And I am going to set a little timer. I'll come around the room, see how we're doing. And I want you guys to draw as many more angles as you can on this worksheet. Don't feel like you have to finish them. This is just a good little practice exercise. But I'm going to come around and help if anyone needs it. I'll pause this for now, and then we'll come back together in a minute. So we did numbers 1, 2, and 3 together. So now I'm going to flip to number 4. Your angle for number 4 should be open nice and wide like this for 125 degrees. Number 5 will be open even bigger for 145 degrees. Number 6, slightly less, but still a large angle here, 130 degrees. Everybody's look okay on the second page? Good. Okay, and don't worry if you didn't get this far. I'm just going to show for anybody that did. This one, I'm not grading this one. This is just a practice thing. Okay, next page, number 7, our 155-degree angle should look about like that. Also a pretty large angle. Number 8, even bigger, 170 degrees. Almost a straight line, not quite. Number 9, 40 degrees, a little one, little angle. Okay, everybody get those okay if you got there? Awesome. And last page, there's just one. 120 degrees should look about like that. How'd we do? Good, 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 good. Okay, so we've drawn some angles. We used a protractor. That is wonderful. Now, let's talk about kind of the categories of angles that we just created. So, back to our note page. We just defined an angle. There's a few more things that I probably should have mentioned this word whenever I first said angle. Does anybody know what this point is called?
Vertex.
A vertex. This point, when two rays are sharing a point to create an angle, this point becomes what's called a vertex. And I like to remember that because an angle usually looks like a V. V for vertex. It's just the name. Yes.
Plural with vertices.
Vertices. Yes, it is. And we'll talk about that whenever we get to like actual two-dimensional shapes. We'll talk about the vertices and the sides and all of that. Very nice. Okay, so now I'm going to start a little bit of a section below that says types of angles. There will be 4 types of angles we will talk about today. I think there's only 4 that exist. If there's more, someone can tell me later. Or, tell me today if you know of them. And we're going to draw little pictures of each and get a little definition. So for this kind of section of my paper, so it's all in one line and all in an area kind of together. I am going to draw a line here down the middle. And then between this edge of the paper and this middle line, another line down the middle. So now I have 2 sections here. And then over here, I'm going to split the other half into 2 sections to give me basically 1, 2, 3, 4 sections all together. And I'm going to kind of box those just so that I've got my sections of my angle types. I know it's not that pretty, but it'll make it easy to look at later. So the first kind of angle we will talk about is called an acute angle. And instead of writing the word angle, I'm going to show you the symbol that we use. You just draw like a miniature angle with a little arc in it. An acute angle. That's the first type. The next type of angle we will talk about, we actually saw just a moment ago on that worksheet. Hang on. One of these days I'm going to figure out my setup. We have an acute angle there. Now we have a right angle, R-I-G-H-T, right angle. So there's the first 2. Next we have obtuse angle. Obtuse angle. And last but not least, we have a straight angle. S-T-R-A-I-G-H-T. 60. And I'll give everybody a moment to write those 4 names down, and then we will zoom in onto each box and give a definition and a picture. Right there. So, an acute angle is an angle, any angle that is less than 90 degrees. So I'm going to write less than 90 degrees. And an example of an acute angle, I mean, it could just be something like this. That's an acute angle. It's less than 90 degrees. What's a right angle? It's
90?
exactly, yes, it's exactly 90 degrees. It can't be 91. It can't be 89. It can't be 89.999. It is exactly and precisely 90 degrees. And a right angle, great way to recognize it is that the ray shoots straight up like that. And we always put a box. So acute is less than 90 degrees. Right is exactly 90 degrees. Any ideas on obtuse, what that might be? More than 90 degrees. More than 90 degrees. So whenever we draw an obtuse angle, make sure that whatever line or ray you're connecting here to the vertex, it can't be straight up and down. It can't be tilted this way. It needs to be a larger opening here. That is an obtuse angle, more than 90 degrees. Actually, one more rule about an obtuse angle. Does anybody know what that obtuse angle has to be less than? 108 degrees. I'm not gonna be testing you on that, but if you want to put that in your parentheses down here, I'm gonna say less than 180 degrees. And the reason it has to be less than 180 degrees, because once your angle is 180 degrees, now it's a straight angle because it makes a straight line. A 180 degree angle is a line. Perfectly straight line. So we would say exactly 180 degrees. That's a straight angle. I will zoom that out a little bit so we can see them all again in case anyone needs to finish writing that. Questions about these for you? Everybody have those written down?
Yeah.
Okay, great. So let me ask you about a few angle measures or pictures of angles and see if we can identify what kind of angle it is. Can I move this? Okay. Would this angle, 150 degrees, would this be acute, right, obtuse, or straight? Obtuse. Why? Because it's less.
than 180.
Good. It's less than 180 and more than 90. Perfect. How about number 2? Just by looking at the picture, would this be acute, right, obtuse, or straight?
Right, so. Oh, wait, so.
If it was a right angle, there would be a box or there'd be a square in there. So it's not right. It's obtuse. It's obtuse because it is bigger than this 90 degrees. This would be 90 if it's a perfect right angle. If it was less than that, it would be acute, but it's bigger. That's obtuse. See that? This is obtuse. Okay. Let's look at this one, number 3. 4 degrees.
Acute, right?
Acute. An acute angle. It's less than 90. It's a acute little angle. That was my favorite way to learn acute angles because they're so little, they're a cute angle. Number 4, 141 degrees. What's this?
Obtuse.
Obtuse. Why? Yeah, it's more than 90. It's less than 180. How about number 5? What's that? Great. A straight angle is a line. It's exactly 180 degrees. Okay. What about this? I heard acute and obtuse. Which one is it? Acute. Why is this acute? It's less than 90 degrees. Remember, 90 is going to be that perfect corner, like the corner of your paper. That's 90 degrees. This one is less than 90. Even though it's rotated, it looks like this is less than 90. So this is acute. Okay. What about this one? Acute. This one's less than 90. If I wanted to turn it the way that we've been looking at it, they're all lined up with my paper. You see how if it was a 90-degree angle, it would be shooting straight up like that? It's actually less. This is acute. What about number 8? What's this?
Great.
Straight.
Straight.
Exactly 180 degrees. Perfect. What about this one?
Right.
Right. Right angles are exactly 90 degrees. Okay, last one, number 10. What's this? Acute. It's a little angle. Acute. Okay, so that's just a few of them we did together as a class. I mostly wanted to just expose you to the names. I'm not going to be testing you over this. It's just good to know what to refer to them as. Again, I'm going to probably mention this a million times this term. This class is going to be different than normal. You're going to notice we move from one thing to the next a lot more quickly than we normally would. And we will just not have time to tackle everything. So you're just lucky this term. It's mostly going to be I'm showing you things, then we have to move on. So I've shown you. Let's move on. Great. Very great. All right. Now we're going to do math with angles. I'm going to show you just one more thing, and I'm going to try to get you out a little early. So I am now, does everybody have this? Can I tear this out?
Yeah.
Okay. Did I hear no or yes? We're good.
Yes.
Okay, I'm going to tear this out. We're going to have one more page of things to write about. It won't be bad, I promise. You guys are doing good. Hard. Okay, so geometry. Wow. Take your notes, continue. Yes, you guys have lunch at 11:55. You still got lots of time. I'll get you out before lunch starts, don't worry. Oh, it's page 2. Okay, so we learned about the segment addition postulate. Guess what? There's an angle addition postulate too. Oh, man. Yes. Okay, so I'm gonna write here angle addition. Yes, angle addition postulate. And I bet you already know how to do this, and you don't even know it. Because it's the exact same thing we just did, exact same process. It's just now instead of it being on a line segment, it's with angles. And instead of inches, degrees. So, let me grab the problem that I made for us. Here it is. Okay. Let's draw a rough angle here. And I'm going to start with a ray facing kind of down like that. And another one like this, so roughly about 140-ish degrees. Doesn't have to be perfect at all. And now I'm going to put a ray coming out of the middle of this angle. So now I've got 2 angles. Whoa. So let's see. What if I told you that the angle right here facing kind of downward was about 45 degrees? I also told you that this whole, both the angles put together is, I don't know, 143 degrees. And what I'm actually going to do is to show that these are not the same measure, I'm going to put 2 arcs on here, 1 arc on here. And what if I wanted you to solve for this missing angle? I'm going to put 3 arcs here. And I'm going to call this X degrees. Yes.
Not sure if 43 minus 45
Obviously, my picture's not to scale. But we'll find that out together. You're exactly right there. Using what you know about the segment addition postulate, what we just did, where we made an equation, set things equal to each other. Does anybody want to explain kind of step by step how you might start to solve this?
You have to let me divide it.
We wouldn't necessarily divide it.
Together,
Add what together?
45.
45 plus 143? Almost there.
X plus 45 equals 143.
Ah, that's it. Okay, so what's happening here is I have, this is my X angle, So I have X. And when I add that to my other small angle, 45, so I'm gonna write a plus there. Notice how the 143-degree angle is just those two angles added together. Can we see that in the picture? This is both angles put together. So when I add those together, I should get 143. Now, my picture is not accurate at all. It's not going to make a lot of sense, but just bear with me here. Okay. Now, before we go on to solving this, do we understand where this equation came from?
So X is the combination of the two in the middle.
So the X is one in the middle. 45 is another one in the middle. When I put those two together, the small ones, I get the big one. The big one is 143. And maybe it would have made more sense if I drew that arc a little further away so it doesn't look like it's the same. That might have made a little more sense to draw it like that. But we're saying that this small pink angle that is X plus the blue angle that is 45, when I put them together, I get the one big angle, the whole, that is 143. How would I solve for X here?
Minus 45.
Yeah, minus 45 on both sides. We get X equals 98. 98 degrees. Degrees, we put a little circle right there. And that would be our answer. See what we did there? Okay, let's look at another one. This time, I'm going to use the edge here, this red line on my paper, and we're going to start with a big 90-degree angle. Perfect corner here. So here's my 90-degree angle. And I am just going to draw a ray coming out here. I'm going to say that this smaller-ish angle is 38 degrees. This bigger angle here, I don't know. 52 degrees. 52. Or would it be? Let me triple check. Something with a 2. I'm bad at mental math. Yep, you're right. Perfect. Okay. If you see this box or this little square, you know this is 90 degrees. Whenever a 90-degree angle is given, they're not going to label it as 90. They're going to put a box. Okay? So I'm not going to write 90, but if you want to make a little note on your paper, the box or the square means 90 degrees, just so you can remember that for later. That means that the whole angle is 90. Okay? How can I solve for X here?
Do the same thing you did on top.
Pretty much exactly the same thing. So what am I adding together? X plus 38. Those are my two smaller angles. X plus 38 equals 90. Good. Perfect. X plus 38 equals 90. Beautiful. How would I solve for X now?
Right now.
Subtract 38 from both sides. And we'll get, just like Erica said, 52 degrees. Okay. So there's a few examples there. Not too bad, is it? Not too bad. Would you guys feel confident enough for me to give you an exit ticket about this and it's just one problem and you turn it in? Yep. Okay, you will have, we still got 20 something more minutes left of class. If you have questions, I'm here. I'm going to make you an exit ticket. You're welcome to wait if you want me to make copies. I will be making copies for the class. I make these by hand. So, you're also welcome to write it out yourself, but if you want it to match, you can wait. I will be making copies. But if you write it yourself, write exactly what I'm writing now. This is your day 2 exit ticket. Okay? Please, you get to keep those. Yes. Please write your name on it. If you don't have your name on it, I can't give you a grade. Okay, so your name. I'm also going to write that this is for geometry. So, let's say solve for missing angle. I'm going to draw an angle. I'll give you, well, I'm going to estimate it, I guess. Let's see. It don't have to be perfect. You can also, if you want to wait, I will be making copies. I'm gonna pass them out to everybody. But if you're just wanting to get started on it now, hang on, I'm gonna write the due date. This is due Friday, the 30th. So not tomorrow, but the next day. And we measure the full angle. Say the whole thing is about 120 degrees. Okay, I'm gonna freeze my screen so that you can all see this if you're writing it yourself, but I'll be back in about 5 minutes. I'm gonna make copies. If you finish, you're free to go. Okay. All right. Feel like it. Oh my gosh. Ending that.